Welcome back to the placement system series. This is going to be the last video in the series, and just because I don't want to be adding on all these different features or whatever to the system when I just want to make it as very basic as possible and just make it very simplistic of a system. And so I don't want to add in too much more than what we're going to be doing in this video. So, what are we going to be doing in this video? Well, I'm going to be adding in the cancel keybind, so the terminate placement keybind. So if you press a certain key, then placement will stop. And then I'm going to be doing a few minor things just to make it a little bit cleaner. There's really only two things that I need to do. And then I'm going to be working on actually getting comments, because in the last few videos I've slacked on that. And just because I have pretty much forgotten about it. But I am in the habit of not commenting, and so I don't want you to get into that habit either. So commenting really does help. Trust me, it really does help. When I go back to my placement module, it is a lot easier because I have comments everywhere. Whereas if I go back to another script, even if it's like half the length, it's way more difficult. Even if it's very basic stuff, it's still much more difficult. So yeah, and then I'll be going over the code one more time just to make sure, like all of the code, one more time just to make sure that everything is making sense. And that's going to be pretty much the end of the series. So hopefully you guys have made it this far. If you did enjoy it so far, obviously, make sure you give it a like, subscribe, share it with anyone else that may enjoy this content. And yeah, join the Discord server link in the description and we'll get started on the tutorial. Alright, so the first thing we're going to be doing is the cancel keybind. So how are we going to do that? Well, really all we need to do is just destroy the object, get everything set to false, and that's pretty much it. So, and obviously bind the keybind. But other than that, that's pretty much all we need to do. So, let's add in our unbind inputs and bind inputs, we need to basically do another line. So we have one for there, and another one right there. So we're going to call this one cancel, just like this. Simple. We already went through what these parameters are. Now we do need to make a new function. So where do we put a rotate function? I'll just put it below that. So we can do a function, local function, cancel. And I don't know if we're going to need any parameters, but we do actually need these because it is a action that we're going to be doing. So we have cancel, then we're going to do input the cancel function. Remember, no parentheses. We can use this as false again, and then we can just put in the terminate key variable that we have right there. And this should work. It's obviously not going to do anything, but it will call this function. So now what do we need to do? Well, pretty much all we can do is we basically do the inverse of what this is doing. All right, so right in here, all we're going to do is basically just say that item, or what do we call object, and then destroy. And then we're going to say that where do we have a grid stored in? So local texture, and that just goes on to the plot. So what we can do is we can probably just say that for this case, you might want to have it a bit more, where you actually have a variable, a global variable for this, or like a function that automatically knows this or something, or it somehow gets that passed in. But for our case, we know what it's going to be called. Since we didn't name it, it's just going to be called texture. And we know where it is. So in this case, we don't need to do anything really that fancy. We can just say that plot dot, or we can probably say find first child, texture, and then just destroy that object. And then if we look down here, we can set the target filter to no. So mouse dot target filter equals nil. Okay, so that's pretty much, that's I think all we might need to do, because everything else is here. And yeah, so let's just go ahead and test this out to see if this actually does work. All right, so we're just waiting here. And okay, so what do we have? Index nil with destroy. So did our thing, well, it did go away. Right, so we have to do this. Because remember, the input state has to be on begin, because otherwise we'll fire it twice and then there is not going to be an object, there's not going to be a texture. So we can basically just copy this since we copied and pasted these variables here. So we can do that. I can't believe I forgot to do that. So now it should work flawlessly. And okay, it definitely seems to be working. And just to make sure that this actually is going to work multiple times in a row, I'm going to make a screen GUI text button. Just move it right over here. Just place. Put this in here. And instead of waiting 2 seconds, all I'm going to do is say that script.parent.mouse button one click connect function. Move that there. Do that. Now whenever we press the button there, it will work. So we can obviously click here. And okay, so here's one thing that actually we need to probably do. So yeah, it is actually doing that. But as you can see, it is working. Cancel placement. It is getting rid of the grid. It's just because there's a glitch that we're going to have to fix, or a bug that we're going to have to fix. But if I were to do this, it works. So what is that bug and how do we fix it? Well, collisions get bypassed because every time we do this, we create a new texture and we create a new object. So pretty much all we have to do is just say that in here in render grid, if, and then find, plot, find first child of, find first child of class. And then we can say texture, then plot, find first child of class, texture, destroy. Should work. And then for down here, every time that we activate, all we have to do is just say that if object exists, object destroy. That should fix it. Hopefully. So, seems to work so far. If we place down something, is not acting abnormally at all. So that fixes that. All right, so now what we can do is we know that this works, so there is that. And so now I'm just going to be doing some very basic stuff. So in here, when we do our making our collisions off, instead of doing this long line here, as pointed out by a viewer on the last video, we can actually just say if V is a base part. I don't know why I forgot about this, but this is a lot simpler and it works just fine. So if V is a base part. Okay, so that's that. The next thing that I'm going to do is another very minor thing. So again, in our activate function, we need to change one very minor thing. And all this is I just want to add task.wait, just like that. And the reason why I'm doing that is just simply because task.wait is the improved version of wait. If you want any more information, then I'll have links in the description to where you can find the information of the whole task library announcement on the dev forum, as well as the task library documentation on the Roblox website, or the developer hub, or whatever the documentation site is called now, because they've introduce a new one. But yeah, so those are the main things that I wanted to do in this video. And so now let's just go ahead and actually add some comments. So the first one that I want to do is get instant C-frame, because what get instant C-frame does is not very, like, what does get instant C-frame mean? If someone just saw this, they'd be like, well, it's one line, but why do we need this function? What does it do? And you'd have to kind of read through, like, what does the code do? Why is it getting here? Why can't it just get this, value that we're getting here? Why can't it just say primary preposition? Like, why? So we're going to explain it in this comment. We can say returns the instant or non-interpolated. Is interpolated a word? I don't know. It makes sense. You all know what I mean by saying interpolated. It's pretty much not moving. It's just the instantaneous position, I guess you could say. So the returns the instant non-interpolated position of the object. Object at any given moment. And so that's pretty much it. So that is a better description than just having nothing. And so there's that. Then we also need to probably explain this. We can just sets can collide to false so that collisions are ignored while placing. I think people will be able to tell that this is not going to affect this since it's not can touch. And then we can, another thing is I do want to explain some stuff in here just because, we can also do it in here. But yeah, this also needs some more commenting because people just look at this big wall of calculations. Like, it doesn't really make any sense. Here we go. Up here, we can just say calculates bounds at each corner, including model scale. That is what we're doing. So then people will be like, okay, I don't have to actually look at what this does and read through this. I mean, this is a little bit more of a simple example, but it still is good to have that if someone doesn't really know that. Another thing we can do is probably just say, in case of multiple textures get added. So, actually, I just realized we don't actually have to do this. We can just return. We don't have to do that. So we can actually return, or so we say, so that multiple textures do not get added. And that basically explains that. Copy this and do the same thing down here so that multiple objects do not get added. There we go. So we have that. So now we're going to go in here. So this is basically, this is first off, calculates y position on, we'll just say that calculates y position because then that should be that. Then this here, so here we go. So this is just going to be calculates either snapped position or non-snapped position. Okay, so that is all we're going to do here. I think this kind of is self-explanatory. This is going to be the offset. So remember, rotation value is the orientation of the model. If it's rotated, then this will be true, I think, or whatever. Or false, I can't remember, but whichever one it is, then it'll switch the offsets. Or we can say calculates offsets and swaps them on rotation to keep object snapped within the grid units. All right, so there's that as well. That should explain that to anyone that is going to come looking at this code. This, we're not going to explain this just because it's kind of just only does one thing. And that should be that. I think that's actually pretty good. Now, I'm not the best commenter, so I could probably do a better job, but, you know, it's just I'm doing what I think would help me if I was coming back to this code. That's really what you want to be doing is, will I remember this? If I will, if it's pretty self-explanatory what this function does, you might not need to actually comment this. Like, this is probably a useless comment. We know that it calculates the position. That's literally what the function says. By the contents of the function, you might need to explain to yourself what exactly is it doing. So now that we've done that, I do want to go over the code one more time in pretty much everything, just to make sure that we are actually understanding what is happening. So obviously in the activate function, or let's actually go back to the constructor function, remember, so we have to set a meta table. We're basically setting this up for the settings, so then everything could be accessed or whatever. We're putting this in the data variable here. So we're putting this stuff in the data array, and then we're going to return that so then the user, whenever they use the module, will actually be able to access this stuff. Or it'll remember this stuff when you have this variable. This will be saved. So that's pretty much that, because we're storing whatever information this returns is going to be stored in here, which is this information here. So then when we use this function or this variable to call this function, this stuff will be saved. So just like that. Then in activate, we obviously do this. So then we make sure that there is not multiple objects that are going to be placed or added. We do some basic setup stuff, so making sure that where we can find the object, if there is, and we can clone it, obviously. Set up stuff here, set variables, stuff like that. Make sure that collisions are going to be ignored. But then we're going to approve placement. So what that means is we're going to make sure that the size is actually what it is. It's going to snap. And then we're also going to make sure that the scale is not too big. And if that goes through, then it's fine. Otherwise, we're going to return that placement could not activate. Then we're also going to check if it's stackable. And if it is, then the target filter will change depending on what we are doing. And the mouse.target filter for not snapping is the placed objects. Otherwise, it's the objects, and then we're not detecting the object, because otherwise it would fly up into the sky, because your mouse is always going to be on the object, and then it would keep flying back or whatever because your mouse is detecting it. So we don't want to, we want to filter that out. Then we do a basic or a simple trick with the interpolation. We set the speed to 1. Then we, if we are interpolating, we are going to set the temp speed to this value over here. And then we're going to set the speed to 1, render the grid, set the parent of the object to placed objects. We're going to wait 1 second, and then we're going to set the, or bind inputs, and then set the speed to the temp speed. So just to make sure that we are actually not going to have it fly in from wherever it was cloned from. And obviously then, once we do that, our value, or our position will be set in this function, which is getting its position from this function, calculate item position. So what this function is doing is it is essentially just calculating the mouse position and then assigning that to the object. Depending on the rotation, the offsets will be different. Remember, this is just half the size of the object. Times 0.5 is the same as divided by 2. And all we are doing is setting or subtracting this from the mouse position on the axes that we're working with. In this case, X and Z. And then we are going to swap them on rotation to make sure that the offsets are the same. Because remember, once you rotate the object, it's almost as if you want to rotate the entire axes, but you're not actually doing that. It's because it doesn't rotate the axes that you have to compensate for it. Because your X will become the Z and Z becomes the X. Because, yeah, the axis does not shift. It's where it is and that's all it is. So, yeah. Then we obviously calculate the stacking position depending on our mouse target. And we, yeah, if we are stacking, we are going to set the position of the whatever the mouse's target is. And then otherwise we're going to make it the plot, the surface of the plot. Then for the grid, we are going to, if we are moving by grid, create a new C-frame value so it's easy to manipulate. Then set a position variable that we're going to need, which is just these values up here, which are the offsets, or the values with offsets. This is the plot C-frame, which we do that because it's easy to manipulate. This is position of the object with the offsets. And then the position is going to be equal to the snap function. This is going to snap the variable or round it to the nearest grid unit. Remember, if we divide by our grid size, then round to the nearest unit, and then multiply. Since we divided here, we have to multiply out here to get the position back to where it was, basically. And then we return the C-frame, or these two values, in a C-frame format. And that will be position times C-frame, or the plot C-frame inverse, which means that we're doing object space. And then we put it back to world space when we multiply them back together, times the offsets again. To remember, we have to do the offset stuff. And then that's all we have to do. Otherwise, if we don't have snapping to the grid, it's a lot simpler. All we have to do is just literally say, whatever your mouse is hovering, that is the position of the object. Although we do have to do one more thing. We have to calculate the bounds. And so we obviously do this. And so that function, all it is going to do is it's going to take in the offsets. And all it's going to do is find the corner. So remember, if you take half the size of an object and you subtract half, or if you take the object and you subtract half the size, you're going to get a side. And then if you add on, like if you have x and y, then if you have half the x, that's going to bring you to the left side of the plot. And then if you add on half the y, you're going to get the top left corner. So that's basically what we're doing. We're just going to get all the different corners, and we're going to have to, add and subtract differently based upon that to get different corners. And then we're just going to add or subtract the offset depending on what we're doing. And we're going to do that for each axis. So 4 corners, obviously. And then we clamp our value in between those values and return a new C-frame based on whatever it calculates. And then we take in, we say that's our final C-frame times C-frame.angles, which what that is this is the same thing as C-frame.angles, but that's our shortcut function right there, times angles, and then we want to multiply it by, or we want to give it rotation on the y, so we are doing that. We put in our rotation value. Okay. Before we do that, though, obviously, we are handling collisions and changing the hitbox color. So what does the collision function do? Well, this is pretty simple. All we do is, if the object exists, we set collided to false first, because if this doesn't pass, then that means we're not colliding. Then we get our collision. We check if it is colliding with anything that is not the object or is not the character. And if it is, collided equals true, break, we disconnect our connection, or function, or our event, return, done. Change hitbox color, all that does is it literally just changes the hitbox color. That's it, depending on if it's colliding or not. Okay, so next we're going to go on to our inputs. All these do is they just bind and unbind inputs, and what that basically means is when you press an input, it will call a function. In this case, rotate and cancel. These are pretty self-explanatory, so I'm not really going to go into depth. All they do is rotate. All this does is cancel. I already went over that code today. Okay, so next we have our render grid. So all this basically does is it just creates a grid texture, sets the texture to the ID that we want it to, and parents it to the plot. We do have to do this first, so then we don't create extras, but yeah. Okay, and finally we have the placement function itself. So what this is going to do is it just takes in a remote function, and then it checks if it's not colliding and the object exists. Then we're going to get the instant C-frame, or the instantaneous C-frame, I guess, or the non-interpolated position of the object at any given moment. And then it's going to send this information that it has about the object to the server. And what is the server going to do? Well, the server is going to check first it's going to create the object. It's going to get the object. It's going to parent or pivot it to the position that it wants to. It's going to check if the plot exists. And if it does, it's going to parent it to that position. Then we're going to check if it's in the boundaries or not. And if it is, then great. Otherwise, we're going to destroy the object and return false. And obviously, if you had something in here, you could then say, if this returned false, then return something in the function and give some feedback to the user. And if it returned true, then you could say return true. Like you could pretty much just say return. You could just return that, and that would do that. So maybe we'll do that. Then after that, if this passed the test, then we are going to also test this, which is the collisions. Same exact function as before. And then we are going to, same exact. And if all failed, or if all didn't fail, we're going to return true, which is what we're going to return here, obviously, because this is the value that we're going to return. And and handle collisions, again, that. And then the bounds is a little bit different. We're just checking if values are greater or less than. So if this is outside of the corner, then, or outside of the x bound, upper x bound, or less than the lower x bound, and the same for the z as well, then we're going to say that we are out of bounds. So that's pretty much it. So if there is if you have any questions, again, make sure you join the Discord server. I am trying my best to answer as many questions as I can, and there's also more people in there that can also help answer questions. So if you need help, it's a good place to get help with this specific series. Now, if you have any suggestions on things that I may have missed, or if you wanted something in the series, make sure you go let me know and in the comments or on the Discord server. I'm probably not going to respond to comments for help on development support. However, if it's a suggestion, I'll try to respond as best I can, at least soon after this video is uploaded. If it's a year, then probably I won't, but yeah. So anyway, hopefully you did enjoy the series. If you did, make sure you give all the videos a like, subscribe to the channel if you want more content like this, join the Discord server, and thanks for watching, and I'll see you in the next video.